All right, hello again, everyone. If you remember, last section we were taking a look at histograms, and so I have one shown here. We had kind of briefly looked at them, and we talked about how a histogram takes a series of data for an individual, and it breaks it up into the counts. How many of those pieces of quantitative data fell within a certain range. So you can usually tell a histogram because down here we have numbers as well as up here, as opposed to if you think back to some of the bar graphs that we had before when we were making a bar graph, we had labels like categories as opposed to numbers. So remember, category, quantitative, that's the difference between the bar graph and the histogram. And so some people even think of this as a histogram is equal to or is made by using numbers ranged, a number range, I shouldn't say range, numbers, a number range as the actual category. A lot of times, and we'll see this in spreadsheet software, some people refer to that as a bin. How many of these fell into this 55 to 60 bin, and how many fell between 60 and 65? All right, so if you were to look in your book at table 1.1, you're going to notice that there's a percent of state population born outside the United States. All right, so I want to show you a few tricks for doing this, but then I also want to talk about a couple of measures when we're looking at a histogram. We want to be able to know the shape of the histogram. We talked yesterday about the spread of the histogram as well as the center. So really, we'll look at the shape last after we have the graph. The spread, you probably recognize this as the range, the small to large number, smallest to largest. The center, also people would recognize this as the median. It is specifically the middle number, not the average, and that's where a lot of people make that mistake. The median is not the average. So we're going to use, though, instead of trying to figure that out, especially finding the median, really difficult when you're looking at this because you got to find, there's 51 states here, so I need to break this into even groups. I need to find the middle number. Well, if you think about it, 51 means I'd have 25 numbers or states above a certain point and 25 states below, and there'd be one state left in the middle because, again, we're using District of Columbia as well. So that gives us a real easy identity for the middle one, but that means we have to have them all in order. So that is where our software comes in handy. So I'm going to jump over to Microsoft Excel. You'll notice that you have these sheets where it's got all of these in here, and I'm just using the table 1. So what's really nice in working with something like Excel is we can change the order of these really easily. Have them all listed in here. What I'm going to do is I'm going to select these top 2 spots. You could select the entire row if you wanted to. I'm just going to select these top 2, and I'm going to click Data, and I'm going to put a filter on those 2. And basically it gives me this little drop-down box. What that allows me to do is I can now sort from smallest to largest, and I'm looking at the numbers here, and it really helps me find some of those things that I want to be able to find right away. So now I can see that the spread is going from 1.2 to 27.2. That probably helps you figure out that there's 26 things in between. That helps me decide, in a lot of times, helps me decide that I want to have bins, in this case, of 5. So I'm going to go from 0 to 5 to 10 to 15. 20, 25, 30. So there are my bins. All right. The other thing it helps us find is that middle number. Remember, there's 51 of these things. So I can quickly find the information that is right in the middle. And it starts by going through 25 of these. And I would go from 2 all the way up to 26. And a lot of people struggle with that because 26 minus 2 is 24. That means there's 24 in between them. But I got to count this first one. So that's 25 of them. And here's the other 25 all the way down, starting at number 28 and then going all the way to number 52 here. A lot of people struggle with that. You can count them, but there's 25 of them here, there's 25 of them here, and the middle one right there, the center or the median, is 6.3. In this case, it's Kansas. It might help in some cases, if you like that, is you can actually delete this row up here, and it might help you with your counting. You know, to say like, oh, here's 1 to 51, so 25 above, and then number 26 is Kansas. I don't do that, but it does help, and you can always use something like Control-Z or whatever the undo button is on the Mac to put that back on there. But anyway, so there's our center. Now, in order to see this, the other thing that's really nice about it is it helps us count these things as well. And, you know, I can go and take a look at how many are between 0 and 5. Well, right there, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I've got 20 of them. So I'll just mark down my 20. Between 5 and 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Between 10 and 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Between 15 and 20, 1, 2, 3, 4, 5. Between 20 and 25, 2. And between 25 and 30, I've got 1. So now I can go over here and say, and I'm not going to get these marked on the right thing, but there's 5, 10, 15, and 20. It's not perfect. But the first one, I've got 20. Second one, I've got 13. Then I've got 10. I've got 5. I've got 2. I've got 1. A lot of times I like to go through and kind of shade in every other one. That's just me, though. It helps me visualize it. But there I now have a histogram, and it shows you the counts in each bin. Now, one of the weird things here is, remember we talked about the center. The center of this is actually way over here at 6.3, even further to the left, like a little bit over in this area. That's where the center or the median of this information is. But look at this graph. It goes off to the right like this. We are going to talk about this graph. First of all, it's not symmetric at all by any means, but it is skewed. And so let's jump back over here and take a look at a few pictures of skewed and symmetric. So here is a graph that is skewed, and so is this one over here. You can tell because it kind of has this tail. You know, the bulk of the information, you know, most of the people were here, but this isn't even close. Like, the graph looks like it should be split inside there. We've got this long tail going away. I would imagine that the center of this graph is really going to be over here. You know, same thing on this one. We've got the center, what should be the center or the median point way over here, and then we have this tail. That's opposed to something that truly looks symmetric because it looks the same on both sides of the graph. So when we talk about it skewed, we can say that it's skewed left or right. This one is skewed right. If you follow the tail goes to the right with skewed right. Some people would say this is a positive skew. Same thing here. This one is skewed left, also known as a negative skew. Again, follow that tail to the left, and that's where you're going to see it. So that is the shape of the graph. In our next section, we're going to take a look at stem plots, which is very similar to a histogram. And then we will be looking at time plots as well. And we'll talk about outliers and a few other key points as we look at it.